Hello, I'm Jared Skeens, and welcome to the Zoom room. Today, I would like to cover Pure Math 1, Coordinate Geometry, Part 4, 3 points on a circle. What I mean by that is you're given 3 points, and we have to come up with the equation of the circle. So this one is a little bit more lengthy in terms of the algebra. And there's two different ways that you can do this. So I'm going to show you both ways. This particular question comes from the book. Again, remember that the circle content is in the new syllabus. So don't have any past paper questions yet to see exactly how Cambridge is going to use this question type with regards to circles. But we can use some of the things that we've learned in the past, both algebraically and geometrically, to help us with this problem. So here's the question. It says a circle passes through and it gives 3 points, P, Q, and R. One is at -1, 4, 1, 6, and 5, 4. Find the equation of the circle. Well, of course, like I've mentioned before, it's always helpful if you draw yourself a little diagram. So here's our circle. It doesn't have to be perfect. We don't know the center and we don't know the radius. We need to come up with the equation. We do know that these 3 points are on the circle somewhere. So again, when you draw a diagram, it does not have to be exact as far as your X and Y axis goes. Just needs to have a general spatial orientation so that you can see what's going on. But I do try to keep it somewhat okay. So here's -1, 1, and 5 on the X. So -1 is the furthest this way. So I'll just put it over here. Here's our point P, and this is the point -1, 4. And then this isn't too far away from it. I'll put it over here. Here's point Q. And this is our point 1, 6. And then over here, 5 is further over. So I'll just put it over here. Call this R. This is the point 5, 4. So it doesn't have to be perfectly arranged. Like I said before in other videos, you don't have time on a Cambridge test to draw an XY axis and make it, perfect. So the general spatial orientation is what we're looking for, helps us to see what we're doing. So there's two ways of doing this. I'm going to show you the more geometric version first, using what we learned in the linear part of coordinate geometry, and also in the second method, it will be more purely algebraic. So you can choose which one you prefer to do. And so let's get started. In the more geometric version or method, what we're going to do is we're going to create chords. So again, we're using the geometric properties of circles from your IGCSE material, plus the perpendicular bisector from the linear part of your coordinate geometry. So when you make a chord, it's just a straight line between 2 points on a circle. And we can make a chord over here with this one. We could make another chord between Q and R, but we're not going to. We're just going to do chords between P and Q and Q and R. Now, using that geometric properties of circles, when you draw a line from from the center to the middle of your chord, it makes a perpendicular. It meets at a 90-degree angle. So here we have to here, and we're going to also do it to this one up here. And so in order to make sure that those are indeed perpendicular, we need to make sure that we are bisecting the chord. And to make sure that we're bisecting the chord, we need to find the midpoint. So the first thing that we're going to do is we're going to look for the midpoint of PQ. And the midpoint of PQ is a -1 plus 1 divided by 2 and a 4 plus 6 divided by 2 means that our midpoint is 0. 0 divided by 2 is 0, and 10 divided by 2 is 5. So this midpoint right here is 0, 5. So since that is the midpoint, then that means the line from the center to the midpoint is a 90-degree angle. And we want to find this midpoint over here. The order in which you do this method doesn't really matter. What we're doing is, what we're creating is these perpendicular bisectors. And these perpendicular bisectors are going to meet at the center. So that's what we're aiming toward. So whether you want to do one perpendicular bisector first and then the other one, or whether you want to do the midpoints as you go, it's up to you. The order doesn't really matter. So this midpoint over here, the midpoint QR, is going to be 1 plus 5 divided by 2 and 6 plus 4 divided by 2. So 6 divided by 2 is 3, 10 divided by 2 again is 5. So this one is at 3, 5. Okay, so that's our midpoint. And because it's perpendicular, that means we can find the slope of the line going through to the center. So first though, we need the slope from PQ. So let's use our slope for PQ. So this information goes with this. And slope of PQ, so our M equals y2 minus y1 over x2 minus x1, which is a -1. So 6 minus 4 is 2. 1 minus a -1 is 1 plus 1, that's also 2. So we have a slope of 1, which means the perpendicular slope is -1. Then we want to look at slope QR. Like I said, doesn't matter if you do all the perpendicular bisector for one separate from the other. I'm just doing midpoints and now slopes QR. So the slope equals QR y2 minus y1 over x2 minus x1. Now, I'm not using the midpoint, I'm using the endpoint to find the slope. You could use the midpoint too, the slope would be the same. Doesn't really matter whether you use the midpoint or endpoint. Slope is the same on the line. I'm just using the endpoints. So 4 minus 6 is -2. 5 minus 1 is 4. So that means we get a -1/2. And the perpendicular to that is 2. So now what we want to do is we want to generate our perpendicular bisector equations. So this one is going to be y minus y1, which is 5, equals m, which is our -1, times x minus the 0. Now in this case, it is important to use the midpoint. You cannot use the P or the Q because you need a point that's on the line. We don't know the center yet, so we can't use that. We can't use these points. They're not on the perpendicular bisector. So we need to make sure we use this midpoint here and this midpoint over here when we're doing that perpendicular bisector. So we're using the 0, 5. So y minus y1 equals our slope times x minus x1. So this gives us a y minus 5 equals a negative x, or y equals a negative x plus 5. So this is our first of our perpendicular bisector equations. Now for the second one, we have y minus, and here is our, here also a 5, equals slope is now 2, and x minus 3. So when we solve this, y minus 5 equals 2x minus 6. Then we get our second perpendicular equation, 2x. When we plus 5, it's just minus 1. So here's perpendicular bisector number 1. Here's perpendicular bisector number 2. And if we solve simultaneous equations, they will meet at the center. Again, this is all geometric based, but of course, algebra is what runs geometry, trigonometry, calculus. So that's why you generally learn algebra first, so that you can then work the rest of it. So we got to set these two equal to each other. And so we're going to end up with a negative x plus 5 equals 2x minus 1. So if we add x over here, we get 3x. And if we add 1, we get 6. Okay, so here's our 3x, that cancels. 3x equals 6. That means x equals 2. So the x coordinate of our center is 2. And then to find the y coordinate, we can plug it back into either one of these. If we plug in 2 here, we get 4 minus 1 equals 3. So y equals 3, and that is our center. So we got the center. Now we need the radius. Well, the radius is from the center to any point on the circle. We can't use the midpoints. They are not on the circle. But we can go to the P, we can go to the Q, we can go to the R. I'm just going to make a straight line over here to the R. And what we want to do is we want to find that distance. This is our radius. So we have the center. We now want the radius. So I think maybe got enough room down here. We'll see. So our R is equal to, that's the distance, by the way. We're using the distance formula, which was also earlier in our coordinate geometry. The square root of our x's, so 5 minus 2, quantity squared, plus, so this is a squared plus b squared equals c squared. The a here, what we're doing is we're kind of creating a right triangle here. So it kind of might look confusing on here, but we're using the Pythagorean Theorem. So just use the formula. 5 minus 2 is giving you our x. Actually, I should be doing it parallel to the x-axis. Might make more sense going this way. There we go. So parallel to the x-axis, 5 minus 2 is 3 squared, and then 4 minus 3, that's 1 squared. So this equals 3 squared plus 1 squared, which equals the square root of 10. So this is 9. 9 plus 1 is 10. So the radius is the square root of 10. Okay. Now what it asks for is the equation of the circle. So we'll try to fit it in here. X minus 2 squared plus y minus 3 squared. Remember, when you're going from center to equation, change the sign. Equals r squared. This is r. So if we square the r, it's going to cancel the radical, so equals 10. So x minus 2 squared plus y minus 3 squared equals 10. This right here is our answer to the equation of the circle that passes through those 3 points. So there's kind of a lot of work there. But what I like about this method is it's using and helping you review a lot of things that you already learned. Like I said, back in IGCSE material, your geometric properties of circles with respect to chords. 2, you're learning your perpendicular bisector, which was in the linear parts of coordinate geometry. And you're also using the distance formula, which was also in the linear parts of coordinate geometry. So I like this method because you're reviewing what you already know you need for the Cambridge exams. But you do have to remember to make the chords and do the perpendicular bisectors. It does take a lot of work, but so does the other method. So let me set it up again, and then I'll show you a different way that you can solve this all algebraically if you prefer to use an algebraic approach as opposed to a geometric approach. Okay, here's the same problem. You notice I left up the answer from the method that I showed you previously using a geometric approach. I've redrawn the circle so that you don't see all those chords and everything in there. Put the 3 points on. This time I'm labeling C as just the H and K with an unknown radius. So these are our 3 unknowns, but we have 3 points on the circle. So what we want to do, if you want a purely algebraic approach, is we're going to take these coordinates, which represent X and Y, and we're going to plug them into the formula. Now remember, we don't know the answer yet. We don't know that this is 2, 3, and 10. So all we know is that it's H, K, and R. So we're going to plug in -1 and 4. So we're going to get a -1, that's the X, minus H squared, because we don't know what this is, it's an H. This is the number of the center right here, plus the Y is a 4 minus K squared equals R squared. Okay, so this 10 is representing R squared. So this is our formula from our X minus H squared plus Y minus K squared equals R squared. So we don't know the answer yet. This is our formula. We're plugging in -1, 4 for the X and the Y. Now, so I'm going to put out here, this is our first equation. If you're doing something purely algebraic, just like in the last one, we had 2 perpendicular bisectors, so I give them subscripts 1 and 2. So if we're going to be doing a lot of algebra, sometimes you want to keep track of what goes together. So we do this, we get a 1 plus H, so plus 2H plus H squared plus 16 minus 8K plus K squared equals R squared. Okay, so that's kind of a lot there. And if you want to, you could kind of organize it a little bit. So if we start with our H squared, say plus K squared, here's plus 2H. And this is a minus 8K. And we have 16 plus 1 is 17 equals R squared. Okay, so we have that. Now what we want to do is we want to do a second one. So I'm going to put this in blue. So here's a second equation. And we're going to use 1 and 6. Do the same thing with 1 and 6. So if I plug this in, we now have the x is 1 minus h squared plus 6 minus k squared equals r squared. Multiply this out. 1 minus 2h plus h squared plus 36 minus 12k plus k squared equals r squared. So part of this depends on how comfortable you are with algebra, specifically binomial expansion. And we put this together and we get h squared plus k squared minus 2h minus 12k. And here we have a 36 plus 1 is 37 equals r squared. And we're going to do it again with this one, 5, 4. So here's our third one. And so we have 5, 4. So we have 5 minus h squared plus 4 minus k squared equals r squared. And we get 25 minus 10h plus h squared plus 16 minus 8k plus k squared equals r squared. And so we put it together and we get h squared plus k squared minus 10h minus 8k, 16 and 25, that's 20, 30, 41 plus 41 equals r squared. So I just put them in the normal decreasing exponential order with the x value first, which is the h, and then the y value, which is the k. And so here we have 3 equations. So what you want to do in this method, after you multiply it all out, is you want to take 2 of them and subtract them. This is the elimination method, actually. So you're doing a system of equations, but because we have 3 unknowns, we need 3 equations. So it's a little bit bigger system of equations than what you're used to. You're used to 2 variable, 2 equations. Well, now you have 3 variable, 3 equations. The principle is the same. And since all of them have squares in it, then we can use the elimination method. So what we're going to do is we're going to subtract. Let's take, since we have a 37 and 17, that makes kind of nice. So we're going to take number 2, and we're going to subtract number 1. So equation 2 minus equation 1, h squared minus h squared cancels out. K squared minus k squared cancels out. Negative 2h minus 2h is a negative 4h. Negative 12k minus negative 12k minus a negative 8k means plus 8k. So that's going to give us a minus 4k. So negative 2 minus 2 is minus 4. Negative 12 minus a negative plus 8 is still minus 4. 37 minus 17 is 20. R squared minus r squared equals 0. So what we see here is when we subtract these, the r's, all the squared terms disappear. And what we're left with is now 2 variables. So what I'm going to do is I'm going to divide this by negative 4. Since I already see a common value, we can simplify it a little bit. Divide by negative 4, and so we get h minus k minus, or plus k, because we're dividing by negative 4. Negative 4 divided by negative 4 is 1. Negative 4 divided by negative 4 is 1. 20 divided by negative 4 is negative 5 equals 0. Okay, so that is our first one. Now we want to do the same thing, but with a different 2. So let's just take the last one. So let's take number 3, and subtract number 2. So it doesn't really matter which ones you take as long as you take 2 different sets, subtract. So again, h squared minus h squared gone. K squared minus k squared gone. Negative 10h minus a negative 2h. So a negative 10 plus 2 is a negative 8h. Negative 8k minus a negative 12. So negative 8 plus 12 gives us a positive 4k. 41 minus 37 is 4. So it's a positive 4 equals r squared. Again, we see something common. We can divide out. And I'm going to divide out a negative 4 so I can keep my, oops, sorry, I put r squared here. R squared minus r squared is 0. Don't know why I put r squared there. R squared minus r squared, 0. So I see a 4 common. I like my front one to be positive, so I'm going to divide by negative 4. That gives me a positive 2h, negative k, minus 1 equals 0. Now we have these 2 equations. Now we're down to 2 unknowns, 2 equations. So the last thing I want to do, this was 1, 2, 3. This one actually makes 4 here, and this one actually makes 5. Okay, so here's equation 4, which is the combination of those 2. Here's equation 5, which is the combination of those 2. Now I'm going to take, and actually, in order to make the k's cancel, because the h's have different coefficients, we can make the k's cancel by simply adding a 1 and a negative 1. So now what we're going to do is we're going to take equation 4 and add it to equation 5. And when we do that, we get h plus 2h is 3h. Positive k plus a negative k cancels out. Negative 5 plus a negative 1 is a negative 6. And 0 plus 0 is 0. Now we're down to a 1 by 1. So notice you started with 3 variables, 3 equations. You put those together to get 2 variables, 2 equations. You put those together, you get 1 variable, 1 equation. So now we get 3h equals 6, h equals 2. Plug it back into whichever one you want. Let's plug it into this up here. So if we plug it in up there, we get 2 plus k minus 5 equals 0. 2 plus k equals 5. Subtract 2, k equals 3. So notice our center is at 2, 3. And now we need the radius. So to find the radius, we could do the same thing that we did last time. Or, so what we did last time is we did from the center to R and did the distance formula. You could do that, but you don't have to, like I said. Or we can plug our h and k back into one of these here and find the r. So let's just take our equation number 1 here, and our h is 2. So if we put in, so we have a negative 1 minus 2 squared plus a 4 minus the k is 3 squared equals the r squared. So we have 2 of the variables. Like I said, you could do distance formula. That's a little longer. You can just plug them back into any one of these 3 equations to get the r squared. Negative 1 minus 2 is a negative 3 squared. 4 minus 3 is 1 squared. Negative 3 squared is 9, plus 1 equals r squared. 10 equals r squared. And there we have what we need. So to get the equation, here's our center, x minus 2 squared plus y minus 3 squared equals, and we don't need to find the r by itself because the formula has r squared. So we just go ahead and put 10 in for the r squared, but yes, root 10 is the radius. So we got exactly the same answer. Here's the trade-off. If you really like algebra, this is a pure algebraic way. 3 unknowns, 3 equations. You break it down from 3 to 2 to 1, and then work your way backwards up to find the other variables. System of equations. If you like that, it's one thought process all the way through. It is a little lengthy, but if you like algebra, that's the way to go. Like I said before, I actually like the first method. You do have to remember different things like chords and how from the center to the chord is perpendicular if it's the midpoint of the chord. Perpendicular bisector, distance formula. There are different thoughts that you have to go through, whereas this is one continuous algebraic thought. So you have 3 different geometric or coordinate geometry things that you have to apply. But I like it because it forces you to review the very things that your Cambridge questions focus on. Okay, so it's up to you. 2 different ways, same answer. You choose the one that you're most comfortable with, but good luck. And this is the end of our coordinate geometry unit. And thank you for joining me in the Zoom room, and see you again next time.